252 million years ago, the planet came as close to sterilizing itself as it has ever come. The details belong to another film. What matters here is what was left behind. Empty ground, empty water, and a scattering of survivors with a whole world in front of them. Among them was a group of reptiles that nobody would have picked out. They were called archosaurs, which means ruling reptiles. And like most names in paleontology, it was handed out long after the fact. At the time, they were unremarkable. What they had was not size, and it was not teeth. It was an ankle. In most reptiles, the ankle is a simple hinge, and the leg swings out to the side. In the archosaurs, the joint was reorganized so that the foot could sit directly beneath the animal, and the leg could carry weight instead of merely holding the body off the ground. They also had an extra opening in the skull in front of the eye, and teeth set in individual sockets rather than fused to the jaw. Small things, structural things. And within a few million years of arriving, this group did something that decided the next quarter of a billion years. It split in two. One branch would lead, eventually, to the pterosaurs and the dinosaurs, and through the dinosaurs to every bird alive today. The other branch would lead to the animal lying in the water at the start of this film. Paleontologists call them the bird line and the crocodile line. And those names are a convenience, because at the moment of the split, neither branch looked like either thing. What separated them was, again, an ankle. In the bird line, the joint became a simple hinge that swings in one plane, which is what you need in order to run in a straight line on two legs. In the crocodile line, the joint kept a peg and socket arrangement that lets the foot rotate, which is what you need in order to sprawl, to swim, and to walk with the body slung low. Two different answers to the same problem, arrived at within a few million years of each other. Everything that follows comes out of that fork. Now here is the part that usually gets left out. The story is almost always told from the bird line, because that is where the dinosaurs are. And the dinosaurs are what people came for. Told that way, the crocodile line is a footnote, the branch that stayed in the river while the interesting one went off to inherit the earth. That is backwards. For the next 30 million years, the crocodile line was not the footnote. It was the empire. It built the largest predators on land, the heaviest armor that had ever been grown, and the most successful plant eaters of its day. It occupied very nearly every role a large land animal could occupy. And the dinosaurs, in the same landscapes, at the same time, were somewhere between 3 and 5% of the animals in the ground. If you had walked through that world and been asked which of these two branches would still be here in 200 million years, you would have looked at the size of them and at the number of them, and you would have been wrong. But you would have been wrong for a good reason. Because at that moment, the crocodile line was winning. To understand what the crocodile line actually was, you have to stop picturing a crocodile. Go to a river flat in the late Triassic, somewhere in what is now Arizona or Argentina or southern Germany, and look at what is standing on the bank. There is an animal 4 meters long with its entire back, flanks and tails sheathed in interlocking plates of bone, laid out in neat transverse rows like tiled paving. Its snout turns upward and ends in a flat shovel, and it uses that shovel to root through the soil for tubers and rhizomes. In some species, a pair of curved bony spikes projects from each shoulder, and in the largest of them, those spikes are as long as your forearm. This is an etosaur, and it is a plant eater on the crocodile line. In the water beside it lies an animal that will confuse you completely. It is 5 meters long, with a long, narrow-toothed snout, an armored back, and short, splayed limbs. And it is lying half-submerged at the margin, with only its eyes and the ridge of its back above the surface. It is not a crocodile. It is a phytosaur. And it arrived at that body plan tens of millions of years before any crocodile did. The one obvious difference is where the nostrils sit. A crocodile breathes through openings at the very tip of its snout. A phytosaur breathed through a raised bony mound set between its eyes, with the whole length of the snout ahead of it completely solid. 2 lineages, 2 solutions, the same job. Where exactly the phytosaurs sit on the family tree is still argued about, and some analyses place them just outside the crocodile line rather than inside it, which is worth saying out loud rather than smoothing over. Then there is the animal standing behind both of them. It is 6 meters long. Its skull is deeper and heavier than a lion's, and its teeth are flattened blades. It walks on 4 legs, but not the way a lizard walks. Its limbs are held as straight columns directly beneath the body, the belly well clear of the ground, and it moves with the deliberate gait of a large mammal. This is a Rauisuchian, and for 30 million years, animals like it were the largest predators on land. And then there is the one that breaks the pattern completely. In the same rocks, there are crocodile line animals that stood on 2 legs. One of them, from New Mexico, is so similar to an ostrich-like dinosaur that it sat in a museum catalogued as one for decades, until somebody looked properly at the ankle. It had a toothless beak, long hind limbs, short arms, and a long balancing tail. It was not a dinosaur. It was a crocodile relative that had independently arrived at the same shape. Put all of that together, and you have a complete world. Armored herbivores rooting along the rivers, ambush hunters holding the water, apex predators walking upright on land, fast bipeds running the open ground, small insect eaters in the undergrowth. Every role a land vertebrate can occupy, filled by one branch of the archosaurs. And the other branch, the one that leads to the dinosaurs, and to every bird alive now, was present in the same landscapes at the same time and made up somewhere between 3 and 5% of the individual animals. Not 5% of the species. 5% of the animals. There is a temptation, knowing how the story ends, to read that as the dinosaurs biding their time. That is not what it was. There is no evidence that the dinosaurs were out competing anything, or pushing on anything, or waiting for anything. They were a minor component of an ecosystem run by their cousins, and there is no particular reason to think that arrangement was unstable. If the Triassic had simply continued, there is every chance the crocodile line would still have the planet. It did not continue. Around 201 million years ago, the supercontinent began to tear. The crack ran roughly where the Atlantic Ocean is now, and along its length, the crust opened and released one of the largest volcanic events in the history of the planet. Lava covered several million square kilometers across what is now eastern North America, West Africa, and Brazil. The mechanism from there is one you have seen before. Carbon dioxide flooded the atmosphere, the oceans warmed and acidified, and the base of the food chain failed. Something close to a third of marine genera vanished. On land, the empire came apart. The Dinosaurs, with all that armor, were gone. The phytosaurs, which had held the rivers for 30 million years, were gone. The Rauisuchians, the largest predators in the world, were gone. Of everything described a moment ago, essentially none of it survived. And here the story does something that almost everybody gets wrong. including me, when I first drafted this film. The obvious assumption is that the survivors were the ones already in the water, because water is safe. They were not. The animals that came through were small, long-legged, and lived on dry land. They are called Sphenosuchians, and they looked less like a crocodile than like a greyhound with scales. About a meter long, lightly built, standing upright, running on solid ground. If you had seen one, you would not have connected it to anything in a river. The semi-aquatic ambusher, the shape the phytosaurs had perfected over 30 million years, did not survive the extinction. It had to be invented again, from nothing, by a completely different animal. That is the single most important fact about crocodiles, and it takes the rest of this film to unpack it. The animal in the river today is not the descendant of the animal that was in the river in the Triassic. It is the descendant of something that was running around on dry land, that went into the water later, and that found the same answer independently. Coming out of that extinction, the entire crocodile line was reduced to a handful of small terrestrial runners. The dinosaurs, meanwhile, walked through the same door and found the house empty. Within a few million years, they were everything. The branch that had been 5% became the branch that was 90%. And the branch that had run the planet for 30 million years spent the next 135 million as a supporting character, but not a quiet one. Here's the part that gets cut from every version of this story. Between the end of the Triassic and the end of the Cretaceous, the crocodile line did not sit in a river and wait. It ran one of the widest sets of experiments in the history of vertebrates, and almost none of the results looked like a crocodile. Start with the sea. In the Jurassic, one group of crocodile relatives went into open salt water and never came back. Over a few million years, they lost the armor plates from their backs, because armor is dead weight in open water. Their limbs shortened and flattened into paddles, and at the end of the tail, the vertebrae bent sharply downward and a fin grew above them, giving the animal a vertical tail fluke of the kind you would expect on a fish. These are the metriorhynchids, and they were fully marine. They could not have hauled out onto a bank if they had wanted to. Several lines of evidence suggest they gave birth in the water, which makes sense, because there is no plausible way an animal with flippers and a tail fin was digging a nest on a beach. They hunted fish and squid in the open ocean for something like 50 million years. Now go the other way, onto dry land. In the Cretaceous, particularly across what is now South America, Africa, India, and Madagascar, the crocodile line produced a group called the Notasuchians, and they are genuinely strange. Many of them had long legs held directly under the body and were built to run, not to lunge out of water and drag something back in, but to run prey down on open ground, the way a mammal predator does. Some had short, deep skulls with tusks at the front, and several of them had something no reptile is supposed to have. They had different kinds of teeth in the same jaw. Slicing teeth at the front, and behind those, broad teeth carrying multiple cusps that met each other in a defined chewing surface. That is a mammal arrangement. It appears in the crocodile line at least 3 separate times, independently, in different parts of the world. And what it is for is plants. There were herbivorous crocodile relatives. One of them, from Madagascar, had a short, blunt face like a pug, leaf-shaped teeth and armor across its whole body, and it was almost certainly living on vegetation. Another carried a shell of fused plates over its back and appears to have spent its time digging. If you handed a paleontologist those skulls with no other information, the crocodile line would not be their first guess, and it would not be their 5th. And then there is size. In the Cretaceous of what is now Niger, there was an animal around 9 meters long with a snout that ended in a strange bulbous expansion of bone. In North America, at roughly the same time, there was one that reached 10 to 12 meters and weighed several tons. That animal shared its rivers with the duck-billed dinosaurs and the horned dinosaurs of the late Cretaceous. We know it ate them because we have their bones, and their bones carry its tooth marks. Take a step back and look at the list. Ocean-going predators with flippers and a tail fin, long-legged runners hunting on open ground, plant-eaters with chewing teeth, armored burrowers, 12-meter river giants that killed dinosaurs. Every one of those is a crocodile relative. Every one of those is gone. What survived out of all of it is the one design that keeps coming back. The semi-aquatic ambusher is not the crocodile line's only invention. It is its most reliable one. That shape has appeared independently at least 3 times in animals that are not closely related to each other. The phytosaurs built it in the Triassic, and it died with them. A group called the champsosaurs built something very close to it and held rivers in Europe and North America for tens of millions of years. And the crocodilomorphs, coming out of the extinction as small land runners, built it again from scratch. When the same shape keeps being reinvented, it usually means the environment is doing the designing rather than the animal. So it is worth asking what that shape is actually for. Look at where the eyes, the ears, and the nostrils sit on a crocodile. All 3 are on one plane along the top of the skull. The animal can float with its entire body submerged and still see, hear, and breathe, which means it can hold a position for hours without being visible from the bank. Nothing else about it has to be fast, because the ambush is a single movement and then it is over. Underneath that shape, there is a set of things that are genuinely unusual. A crocodile has a 4-chambered heart, like a bird and like you. But unlike either of you, it has a connection between the 2 outflow vessels and a valve that can close off the pulmonary artery. When it dives, it can shut the lungs out of the circuit entirely and send the blood straight back around the body. It is a switch for turning off the part of yourself that needs air. Its metabolism runs low enough that a large individual can go through a year without eating, living off fat and muscle. Its bite is the strongest ever directly measured in a living animal. And the animal that owns that bite is also one of the more attentive parents in the reptile world. A female builds a nest, guards it for months, answers the calls of the hatchlings from inside the eggs, opens the nest when they are ready, and then carries them down to the water in her mouth, a few at a time. In some species, she stays with them for a year or more. Put all of that next to each other, and a pattern appears. Sit still. Spend nothing. Wait as long as it takes. When the moment arrives, spend everything at once, and then go back to spending nothing. That is not an unsophisticated animal. It is an animal built around a specific bet about how the world works. And the bet is that scarcity is the normal condition, and abundance is the exception, which turned out to be an extremely good bet, given what happened next. 66 million years ago, an object between 10 and 15 kilometers across struck the shallow sea off what is now the Yucatan Peninsula. That story is told in full elsewhere, including by this channel. What matters here is the filter it applied. For a period of hours, re-entering debris turned the sky itself into a heat source. And anything that could not get underground or underwater was in serious trouble. Then the sulfur aerosols shut out the sun, photosynthesis stopped, and the base of every food chain on land failed at the same moment. Everything above about 25 kilograms that depended on fresh plant or animal matter eventually ran out. Every dinosaur that was not a bird died. Every flying pterosaur died. The great marine reptiles died. And the crocodiles walked through it. Not all of them, but as a group, comfortably. Look at what they had going in. They were mostly in fresh water. And freshwater systems are the one place on Earth where the food chain does not run on living plants. It runs on detritus, on dead material washing in off the land. And dead material was the one thing that world had in abundance. They had a metabolism that could idle for a year. They were, by the standards of the late Cretaceous, small. And they were not fussy about what they ate. That is the same list as the birds. Small, sheltered, slow-burning, undemanding. The two branches that separated at an ankle joint 250 million years earlier came through the same door for the same reasons on the same afternoon. And here's the last thing. People call the crocodile a living fossil, and they mean it kindly, and it is wrong. A living fossil implies an animal that stopped, that found its answer early and never moved again. The crocodile line never stopped moving. It went to sea and grew a tail fin. It went inland and grew running legs. It grew chewing teeth and ate plants. It grew to 12 meters and hunted dinosaurs. It tried, at one point or another, most of the things a vertebrate can try. What you are looking at in the river is not an animal that never changed. It is the one branch of an enormous experiment that happened to be holding the winning shape when the sky went dark, twice. The eye at the surface is 250 million years of trying things. It is still trying. It just has no reason to hurry.